Question 6. So, using the factor theorem, we just simply have to substitute minus 3 into the function and check that we get 0. So substituting minus 3 in here, we get this, which equals 0, therefore x plus 3 is a factor. Now for part B, we've got to factorise this completely, so we do this using our algebraic long division. So we have the function divided by x plus 3, which I've done over here. So here goes. So we say to ourselves, x times what gives us minus 6x cubed? Well, that's minus 6x squared. So minus 6x squared times x is minus 6x cubed. Minus 6x squared times the plus 3 is the minus 18x squared. This take away this gives us plus 11x squared, and we draw down our plus 40x. We then move on to our second cycle. X times what gives us the 11x squared? That's the 11x. So 11x times the x and 11x times the 3 gives us our 33x. 40 take away 33x is 7x, and draw down the plus 21. And then our third cycle, we say to ourselves, x times what gives us our 7x? That's our plus 7. So it's 7x plus 21, and of course there's no remainder, which there mustn't be because obviously this was a factor. So we've partially factorised it now. We've now got it, we've broken it down to x plus 3 and this as our second bracket. I've done that down here. Now I've taken the minus 1 out of here. I've basically factorised by minus 1, which just reverses all the signs in the bracket. So we've got 6x squared minus 11x minus 7. And then factorising that, I get 3x minus 7, 2x plus 1. So my final answer is x plus 3 times 3x minus 7 times 2x plus 1. But we need a minus in front. I like to put the minus 1 in front. I think the answer scheme just puts a minus sign, but it's the same thing. Now for part C, we're being told to hence solve this equation, and we can see that basically we've got 2 to the y is really just being substituted in place of x. Okay, x we've got 2 to the y, here we've got 2 to the y squared, and here we've got 2 to the y cubed. So our starting point is we know that 2 to the y is our x. So looking back at our previous answer, our three values for x would be minus 3, minus a half, and 7 to the power of 3. Now in theory we're considering all three of these, but 2 to the y just can't be negative. You can never get an exponential curve into its negatives, so we have to be using the solution 7 over 3. So 2 to the y equals 7 over 3 is what we need to solve. So I've logged both sides and then divided through by log 2, so y equals log 7 over 3 divided by log 2, which is 1.22 to 2 decimal places.